Hey everybody, we're here on FreeCodeCamp.org. I'm going to go to the curriculum page. On the curriculum page, as always, we have the Try Coding Challenge of the Day section. You can hit the start button to do today's challenge, or you could follow me along to the archive. We're going to go back to August 15th. And on August 15th, we have this challenge, and I don't even know how to say the name. Jabelmud text challenge. I think they mean jumbled, and that gives us a hint that we're going to be jumbling text, right? Given a string, return a jumbled version of that string where each word is transformed using the following constraints. The first and last letters of the words remain in place. Cool. All letters between the first and last letter are sorted alphabetically. The input strings will contain no punctuation and will be entirely lowercase. So that makes things a little bit more simple, I would think. We don't have to worry about any symbols. We don't have to worry about uppercase and lowercase differences. And we can look at our 4 test cases here. We turn hello world into hello Walord. We turn I love jumbled text into I love Jabelmud text, and so on. And you notice, I want you to take note that we may have a 1 character long word. That'll come in handy noticing that later. So where do we begin? We can begin by taking the text and breaking it into an array of words. So if we call the split method the string split method, and we split it on the space character, we're going to end up with an array of words where each item in the array is a word. Then we're probably going to be iterating over the word because we want to work on each word separately. We want to jumble the middle part of the word but leave the first and the last character the same. It would be useful to have a string ready to insert our new content into from the array, and then we'll just be returning that result. And so we'll use our handy dandy traditional for loop to iterate through the words array. And on each item in the words array, we know we're going to want to have the first and the last letter remaining in place. So let's look at that first constraint. We are packing our work into the result string. And to get the first character in the word, we could do this because technically we're thinking of the words array as a multi-dimensional array. The first dimension is the word. The second dimension is the characters in the word. And so we take the word at this iteration and we get the first item in that word, the first character in that word, and that will be our first letter. Then we're going to have the scrambled bit. And for now, I'm just going to leave that right here, or I'll say jumbled, right? Jumbled. And we'll go back to that. But for now, we'll just put that as a placeholder in between. And then to get the last character in the word, what do we do? Same thing as the first, but instead of getting the 0th element, we will get the words sub I length -1 index. So this will get the length -1 is the index of the last letter. And so now we can feel reasonably confident that we have that word. We haven't jumbled it yet, but we have the first and the last letter for that word in our result string. And we will have to add a space to it to be ready for the next word, for the next iteration of our loop. But we don't want to add a space if we're on the last word. So if on the last word, we don't want to do this, but otherwise we want to add a space after this content we just put into the result string. Make sense? Okay, well, how do we jumble it then? We can take a substring of the word. So here's our word. We can take a substring, and that would be starting at the second letter in the word, which is index 1, and continuing on until the second to last letter. So the last letter using substring would be length, but we want the second to last letter, right? So it can be maybe a little confusing when you're working with arrays and you know that the last item is, length -1, but substring, it ends its operation before, so it's non-inclusive of the second argument. So we can use -1. If it was inclusive of it, we would use -2. But it's non-inclusive, so we'll use -1. I don't know of a better way to describe that, but you can try out different things with substring and you'll end up seeing the result that I'm trying to describe. Next, we can split it because we have that string content. So if our word was world, right? If our word was world and we just took the substring it would be that, right? Now we want to split that, which is the result of our substring here, into an array. So now that array would be, I'm just trying to illustrate what's going on so you're able to have it in your head, because I'm kind of realizing using these, I'm used to it, but if you're not used to using these string methods and chaining operations together like this, it can be hard to imagine in your head what is going on as each successive chain operation occurs. It's easier to imagine things when you're working with a for loop and you're manually manipulating the string. That's easier to illustrate in your head and imagine as you're working on it. Chaining operations like this, going from string to split, I understand it can be harder to imagine right off the bat, but that's something you're going to have to get used to. Just know that we have, on line 10, we have the words at item I. Let's imagine that's world, like this. And then we take the substring from the second item to the second to the last item in the string. We end up with this substring. And then we split it into an array. We end up with an array like this. And now we need to sort it alphabetically. And I believe our sort method on the string data type allows us, if we're working with just alphabetical characters and we know that they're all lowercase, we can call sort without any arguments, and this will know how to sort those letters because they're all in the same Unicode subset. Uppercase is in a different subset. So if we had uppercase and lowercase letters, this wouldn't work out the way we want, I don't think. We would have to work with either setting them all to the same case before we do this, or we would have to add a callback function here to specify what to do as items come through the sort function. And we could do that. What's happening here when we don't specify an argument, I think, is if A is less than B, and that's talking about the Unicode number, we return a -1, I think. We're not going to keep this code, so it doesn't have to be exactly correct, but I'm just trying to illustrate what this is actually doing. I'm pretty sure this is. So if A is before B in the Unicode set, we return -1. If A comes after B in the Unicode set, we return 1. And then if neither of those are true, it's the same letter, so we return 0. It doesn't have to do any sorting. Those two letters are the same. But we don't have to do that because sort knows how to do that internally. Don't ask me how or why. I haven't looked at what sort does under the hood, nor do I want to. So we sort them alphabetically, and what we saw in our test case here, we know that the sorted result is L, and I'll use single quotes for some reason. It doesn't make a difference, but it makes me feel better. L, O, and R. So that's what happens after we've sorted those array of items. And now we want to join them together without a space between them, without anything between them. And so we end up with the result being lore. That's what's happening on line 16. So there we go. You could, if you are uncomfortable with using chain operations like this, you could just do this. Set up a variable for each one, and this allows you to kind of check the result as you go, as you work through it. So there's no shame in doing this. Oops, and I should do jumbled. You have to make sure to pass the preceding variable into the next operation. And so this would be sub, and we could call this, I don't know, array like we did before. So this is the array of the string characters. And now this is the sorted array. And now this is the resulting string. Right? We could do all of this, if that makes you feel better. And then we would just have to put this back into jumbled, really. So like you could do this. And that's fine if that's easier for you to recognize right now when you're just beginning to learn this stuff. But we don't need to use the memory to set up all these variables. We can just chain these operations together. And when we do that, we wind up with a really long line. So that's why I usually wrap each of these items onto their own line and indent them together so that I can kind of look down vertically and see, okay, I'm working with this word, and then I am calling substring on it. So let me imagine what that is. And then I'm calling split on it. Let me imagine what that is. We sort it, we join it. And when I imagine what that is at the end, that's what's going into this variable. And that's what's going into the middle of what we are packing into the result variable up here. And yeah, I think that'll do it, right? This meets all the requirements of what's described here. All the letters between first and last are sorted alphabetically. We sort them alphabetically, and we put them between the first and last. This first constraint we talked about, the input string will contain no punctuation and be entirely lowercase. That helps us a lot because when we sort them, we don't have to consider, hey, is this lowercase, uppercase, etc. Yeah, and I believe that should do it. So hold your breath, run the tests. Oh, we still have one thing left. And I mentioned it when we were looking at the requirements. We have one letter items. So what do you think is happening here when the letter I as a word goes through our code? That's one way that you could, if you didn't know what was going on, hey, why doesn't this work? All this code should work. What's going on? When you're debugging it, you would end up seeing, so I will guess that it has multiple I's all packed into one word. There's like 3 I's. Yeah, 3 I's. So if you don't want 3 I's and you want just 1 I, you just need to consider the condition where a word is one character long. And if that's the case, we want to just put that word with a space after it. You know, we do the space, we put that word into our result. And then we don't want to run the rest of this code. We don't want to jumble. It doesn't have the rest of the words. So yeah, so that is the issue. Like I comes here, the letter I doesn't have a substring at index 1. It doesn't have an index 1. It might just come up with I. So we're saying I plus I plus I. And that's what we saw in the results. Yeah. Sorry, side tangent. I just kind of wanted to talk through that. Yeah, we have 3 I's in the results. And so you can imagine this results in just the letter I, this results in just the letter I, and this results in just the letter I. And then we add a space. So to avoid that, we just use that one character and we add a space after it. Then we continue on with the rest of the iterations of the loop. We don't complete this loop. We don't want this code to run. We just want this code to run. So we continue, and that will automatically increment our iterating variable I to the next iteration, and it'll start the next loop. Yeah, pretty sure that's what that'll do. And we run the tests, and we have completed the challenge. Let you get back to your day. Thanks for listening. Thanks for watching. Really appreciate you. Let me know the quality of these videos, like the visual quality. Someone commented on a previous video saying that it was really blurry because I was zooming in while I was editing the video, and that ended up having a bad result. I zoom in on the browser now, and so if something like this or something like this is an okay quality, and you can see all the text on the screen, you can see the code, let me know in the comments. And obviously leaving a comment will help me in the algorithm. So if you want to comment anything, that's fine. Comment a thumbs up. Good luck out there, my friends, and I will talk at you again soon.